and doesn't really work. So we're going to look at another method here using the graph to help us. Again, it's not the most efficient, but it does work. So let's look at the next process. Okay, so we're going to actually graph these. Okay, we're going to graph them as if they say y is less than or equal to or greater than or equal to and so on. And then we're going to try to figure out some points that work. So I'm going to start, this one's already got a 0, so I'm going to just go ahead and graph. It's in standard form. Whatever form it's in, you use the methods we've been doing for graphing. So my vertex is going to be, the x value is negative b over 2a. So for this particular one, that's negative 4 over 2 times 1. So my x value is what? Negative 2. Now if I plug that in, I get 4 minus 8 is negative 4 plus 3 is negative 1. So my vertex is negative 2, negative 1. And then if I use my y-intercept, which is 0, 3, 1, 2, 3, and it's solid because it's or equal to, and I'm going to mirror that point. So I'm going to go over to, alright, so now we don't shade in the same way because we're solving. We're looking for what x values make this true. So if you remember when we did this with linear ones, we would go onto the number line and let's say it was the 1 and it was all the numbers bigger than 1 but not equal to 1, and maybe I had stuff that, or maybe it was the other way and it pointed, was everything less than 1, so I'd shade the other way. Okay, so it's going to be something similar to this, except we're just going to go ahead and put it on the xy axis, but it'll be along, since it's just x values, along the x-axis here. So, alright, so I've got my graphs, and now what I'm going to look at are, just along the x-axis, I want to plug in an x value in this region, in this region, and in this region, and see what makes this thing true. Okay, so what I usually start with is 0 if the graph doesn't actually touch 0. So if I plug in 0, I get 0 squared is 0 plus 0 plus 3. 3 is in fact bigger than 0. So since this space is true, I am going to shade along the x-axis in that direction, and I'm going to make it a bracket because I've got an or equals to. Alright, so then I'm going to look at, let's say, negative 4. Okay, if I plug in negative 4, I get 16, minus 16 is 0, plus 3 is 3, and again I get 3 is greater than 0. So chances are, just like when we did the linear and the absolute value ones, it's either going to be on either side or it's going to be in between. In this case, it's on either side. So the stuff in between doesn't work. Alright, let's look at the next one. Notice I'm missing the c value. So I've got x squared minus 4x plus 0 is less than 0. So if I want to solve this one, again, I've got standard form, so I'm going to do my vertex is negative b over 2a, so that's going to be 4 over 2 times 1 is 2, so I get my x value of 2. If I plug in 2, I get 4 minus 8 plus 0, so I'm going to get 4 minus 8 is negative 4. So I've got 2, 1, 2, 3, negative 4. And then if I plug in 0, I get out 0. So 0, 0 is on my graph, and I'm going to mirror that point. Alright, so now I'm going to pick, I can't pick 0 to plug in because it's already on the graph, so I'm going to choose negative 1. If I plug in negative 1, does it give me something less than 0? Negative 1 squared is 1, minus 4 times negative 1, so that's plus 4. So I get 1 plus 4 is 5. 5 is not less than 0, so this region doesn't work, which means this one won't either. It's either on either side or it's in between. So I'm going to shade with parentheses in between because I don't have the or equals to underneath. This to me looks kind of weird. I prefer putting these on a number line. So I could do like what we were doing when we did the linear and the ones with absolute value and all of that. For this part B, I could say, here's 0, so I could be between 0 and 1, 2, 3, 4 in this case, so I would shade it like this if I were to put it on a number line. Alright, so let's look at the third way to do this. I'm going to, so for example 3, we can use the graph, but I think we're just going to go ahead and do the third method. Okay, this method though only works if they are factorable. So that's the one, we're just going to focus on the ones that are factorable. So you'll get a little more practice factoring. Okay, so let's move on to example 4 and look at these problems. They have to be factorable in order to solve. Alright, so I've got x squared minus 2x, and I'm going to move the 15 over. Okay. Alright, so in order to factor, remember we need two things that multiply to a times c and adds to b. So that's going to be multiplies to negative 15 and adds to negative 2. So I've got my x squared, my negative 15, so multiplies to negative 15 because it's 1 times negative 15, and adds to negative 2. So I'm going to say that's negative 5 and 3. So factoring that out, that's going to give me x, and then minus 5 and plus 3. So this factors to x minus 5 times x plus 3 is greater than 0. Okay, so what I want to know is what do I plug in for x to get something bigger than 0? In order to have bigger than 0, then I know that either both of these quantities have to be positive or both of them have to be negative. Okay, so if I plug in 0, okay, so I'm going to start with 0, and I've got 5 as a barrier, and I've got negative 3 as a barrier because that's what makes these things equal to 0. Okay, those are your x-intercepts. So if I pick 0 and plug this in, I get 0 minus 5, so that's negative 5 times 3. That gives me a negative number, which is not bigger, so it's not going to be between them, it's going to be on either side. And I'm going to use parentheses because it's not equal to. Alright, I'm going to do one more, and then I'm going to have you do C and D. Alright, so this one's already got 0 on the one side, so I'm just going to go straight to factoring. So I need two things that multiply to 2 times 3, which is 6, and adds to negative 7. So that's going to be negative 6, negative 7. I've got 2x squared, 3 down here, negative 6x, whoops, sorry, that should be negative 1. Alright, so now the 2x squared is going to have an x and an x, but it's also going to have a 2 and a 1. I'm going to put the 2 on the side because that turns into negative 6 by multiplying by negative 3, and x times negative 1 gives me negative 1. So my factored form is 2x minus 1 times x minus 3 less than or equal to 0. So the first thing I'm going to do is plot those points on the number line. So I've got 1, 2, 3. And we're going to say 1/2 is here. Alright, so I'm going to start with plugging in 0. If I plug in 0, I get negative 1 times negative 3 is 3, which is not less than 0. So since that's on the left side, that means the outside isn't going to work, and I need to shade. Oops, that should be here. So we're going to be between 1/2, and 3. Now if you're not sure, plug in 2. If I plug in 2, I get 3 for this piece and -1 here, so I get a positive times a negative, which is in fact less than or equal to 0. So my values are going to happen in between. So I want you to try C and D. And I also want you to go ahead and try just graphing this and then trying to determine some solution areas as well. So you're just going to do A from example 3 as an additional example.